All right, so today we're going to find exponential and logarithmic inverses, and we're going to solve exponential and logarithmic inequalities. And so I hope you remember, we learned it earlier in the unit that logarithmic and exponential functions are inverses of each other. So when you're finding the inverse of logarithmic, it's going to be exponential and vice versa. So we tried it without looking. When we found inverses before, do you remember the first step? Like it would be any kind of function, and you want to find the inverse of it. Do you remember what you do? Switch x and y. Good. So that's going to be the same first step that we're going to do for exponential and logarithmic. And so f of x is basically y. And so what we'll do is make f of x, x, and make x, y. All right, and then the next step is just to solve for y. And so this is an exponential equation that we're going to solve for y. And so do you guys remember the first step here? What you want to do first? All right, you want to get the exponential expression by itself. And so what would you do first to do that? Yes. Now when we did this earlier in the unit, you could actually add and get like 12 or whatever. Here we can't, so we get an expression. All right, and then what would you do? Yes. Okay, now we want to solve for y, and we can't solve for something when it's up in an exponent, so there's only one way we can get an exponent down, and it's to use logarithms. And so we are going to do a logarithm. We're going to write this in logarithmic form. What is the base? 2. What is the argument? X plus 15 over 3. And it should equal the exponent. A logarithm always equals an exponent. All right, and there's one more step to solve this for y, and it's to subtract 4. Now, when you subtract 4, do you think that you could subtract it from anything inside these parentheses? No, the argument is stuck. The only way you could change it is if you use the properties of logarithms, but subtraction is not a property of logarithms. So we are going to write this in inverse notation. So instead of f, this is going to be f inverse. It should be equal to that log minus 4. So this function here would undo everything that this function does. All right, any questions? Okay, let's look at example 2. This time we have a logarithmic function. Its inverse is going to be an exponential function. We're going to start off the same way and switch x and y. Whoops, I forgot to make my x, y. All right, and so what we want to do is isolate the logarithmic function. So I'm going to subtract that 6. All right, and then I'm going to divide by negative 3. Now, before we go further, I want to talk to you about this dividing by negative 3 expression. more than likely, this would be on the multiple choice part, not on the free response part of the test. And even if it was on the free response part, it's still not considered to be simplified form if you leave a singular negative number in the denominator. It's just not considered simplified. So what you would do is you would go back and you would change all the signs. So this would be negative, this would be positive, this would be positive. Also, I feel like on a free response question, so I'm actually fine with you guys just doing negative x plus 6 over 3, as long as you understand that that means the exact same thing as 6 minus x over 3. So it doesn't really matter what order you write the x and the 6 in, as long as the signs stay the same. But on a multiple choice test, I can almost guarantee this is how they will write that. So as long as you know they mean the same thing, I'm fine. All right. So now, what do you guys think we need to do to get the inverse? Yes, ma'am? About the whole negative 3 thing? So it's not considered simplified if you leave this negative in the denominator. Now, if it had been multiple things like x minus 6 or x minus 3, that's fine in the denominator, that kind of negative. But a singular negative integer in the denominator is not simplified. So what you do is just change all the signs. So it's like you divide by a negative. So the x becomes negative, the 6 becomes positive, and the 3 becomes positive. So the x is negative, the 6 is positive, the 3 is positive. It's just an equivalent expression that's considered to be simplified. Okay, so what do we do now to find the inverse? What type of function is going to be the inverse? Exponential. So we want to write it as the exponential expression. What is the base of my exponent going to be? I think I said that weird. What is the exponent going to be? It's going to be kind of weird. Yeah, the whole 6 minus x over 3. That's kind of hard to write it as an exponent. And it should equal the argument. All right, and then we just have one step to add that 4. Obviously, we can't add it to the 5. We can't add it to the exponent. It's just going to be hanging out at the end. And this is going to be g inverse of x. So that expression would undo everything the original function did. So these obviously are almost impossible to do in your head. So definitely put in the work and get all the steps. All right, now example 3 looks like it might be more difficult than what we just did, but I actually think it's easier. But you have to understand what's happening. So h of x is that exponential function. And we know k is the inverse of h. We want to know for what values of x does k of x equal 1. We actually can do this without finding k, without finding the inverse. So saying what values of x does k of x equal 1 is also asking when h inverse of x equals 1. So we're trying to figure out what x you can put into the inverse and get 1 for the y. So if we want to use h, would 1 be an x or would 1 be a y? It would be an x. So all we have to do is take the function we already know and put 1 in for x. It's super easy. But it's a lot to think through. I'm not saying the concept is easy. I'm just saying once you figure out what to do, it's going to be easy. You just put 1 in for the x, which means we're just going to do 3 squared, or 9 minus 2, which is 7. So if h of 1 is 7, h inverse of 7 is 1, which means k of 7 is 1. Now, today on your assignment, you're going to be able to just fly through those because you'll be like, oh, she just did one like that. I'm just going to plug it in. If there is one on the AP exam in May, there's a good chance you are going to go ahead and find the inverse and plug it in, and it's still going to work. It's just going to take you longer. The good thing about the AP test is you have way too much time to do the multiple choice, like way too much time. You will be done and probably sit there for 30 minutes. So you've got loads and loads of time to do it. Calculus, not so much, but pre-calculus, there's plenty. All right, so now on the back, we're going to solve some inequalities. And we have solved quadratic, polynomial, and rational inequalities. And when we learned it, it really challenged you. So I feel like now, when we do it this time, hopefully, there's a few extra things we have to do, but I think it's going to feel way easier than when we learned it the first time. All right, so one thing that is different that you have to think about is the domains. And so, like on polynomials, there was never a restriction on the domain. Logarithms, like every logarithm, well, not every logarithm, just kidding. Most logarithms, there's a restriction on the domain. Now, what I don't know is about this one. So we're gonna actually use our calculator on it. But on x plus 3, I know that this argument has to be positive, which means that argument, I'm going to draw some arrows, that argument, x plus 3, has to be greater than 0. So what does x have to be greater than? Negative 3. Okay, let's look at that other one. Okay, so this is the graph of the argument. This is not the graph of the logarithm. It's just the graph of the argument. We need this argument to always be positive. So what do you guys notice about it? It is always positive. Everywhere it's graphed above the x-axis, that means it's always positive, which is awesome. So, because that means I don't have to worry about it. All right, now we are still going to do a number line like we did before. The difference is this number line is not going to go in both directions. This number line is going to have an endpoint and point to the right. What do you guys think that endpoint is going to be?
0.
Not 0. Look at what we wrote in green. Negative 3. Why do you think I'm pointing to the right and not to the left?
It's greater than -3.
Very good. Okay, so we have to do that on all of these. It's going to take a second. It's a little bit of extra work, but I think you're going to be fine. All right, so what we want to do is find when f, which is this whole thing, is greater than 0. So I'm just going to write that out. All right, now at this point, there's two things we can do. We can bring these logarithms together using, would we use multiplication or division? Division. Or is there something else we could do that maybe will make this easier, where we don't have to use a property of logarithms? We cannot drop the logs now because they're on the same side. But we could fix it so they're on opposite sides, right? Yes. Let's not, I know I did that one day, and I feel like that's kind of messing you up. So let's not think about that. Let's think about it differently. We're just going to move this to the other side. And since it's subtraction, when we move it to the other side, it's going to be addition. I kind of feel bad that I said that one day. That works for subtractions. If they both have as subtractions, you can switch them. If there's addition, it's just, I shouldn't have said that. I'm sorry. All right, so we are going to move that logarithm to the other side. by adding it. All right, now we kind of have log equals a log. It's not really. It's log is greater than a log. But because you have one log on each side, we can drop off the logs. We couldn't before because they were on the same side, but we can now. I know this is kind of weird because we have that greater than sign in the middle, but we can still keep doing the same thing we do if there's an equal sign. So I'm going to subtract that x and subtract the 3. All right, what do you guys think we do now? We're going to factor. All right, so on this number line, we need to know what values of x make this equal to 0. And so what would they be? 4 and 1, right? So those numbers are going to go on the number line. Because if this changes from positive to negative, in between where that changes, the function is going to equal 0. So we need to know when it's 0. But the answer to the question is when you multiply these together and you get something greater than 0. So I'm going to write it over here. You probably don't have to, but I'm going to zoom in and I want you to be able to see it if I'm talking about it. All right, this is what we're testing. So we're going to figure out in each region, if I plug in numbers for those x's and y's, if I get a positive or a negative. All right, so I am going to plug in 0, 2, and 5. I'm going to go ahead and put my endpoints for my regions. Are they going to be open or closed circles? They're going to be open. All right, so I'm just going to plug in 0. And for both those x's, that's going to be a negative times a negative. You also, if you wanted to, could plug in 0 here by just getting rid of those x's, and it's obviously a positive 4. All right, and then I'm going to put 2 in for both of these, and so that's going to be a negative times a positive, which is a negative. And then I'm going to put in 5, and that's going to be a positive times a positive. What do we want?
Positive.
We want a positive. We want to know when this is greater than 0. All right, so I'm going to graph the solution region, and then I'm just going to describe it using interval notation. So we're going to be from -3 to 1, and also from 4 to infinity. All parentheses here. We don't include any of the endpoints. All right, so that wasn't too terrible. We did need to use the calculator a little bit because I didn't really know about that first parabola. But we're going to do example 5 without the calculator. Okay, so this one is set up slightly different. It's actually going to be easier in the long run. We want to know, we have g and h. We want to know when g is less than h. But we still need these domains. All right, so this is a quadratic. If I put something in for x and I square it and then add 2 to it, is that ever going to give me something that's not positive? Yeah, this is always positive. So we don't have to worry about it. All right, x plus 4 we have to worry about a little bit, but it's easy, super easy. We know x plus 4 has to be greater than 0. So x has to be greater than negative 4. And that is going to be the endpoint of my number line. And once you take care of that, from there it's just solving. So I'm going to take g and set it less than h. So this one has one last step. We can go ahead and drop off the logs, right? Okay, yes, we can. Right, and then we'll get everything on one side. And then we can factor. So that's what we're going to use to do our testing for our number line, but we need 2 more points on the number line, and that's going to be -1 and 2. And then we're going to take a point from each region and plug into our factors and see if we get positives or negatives. And you're probably going to see a pattern develop. All right, and this time we wanted negative. So there is one solution region, and it's going to be between -1 and 2. So all those values are going to make g less than h. All right, what questions do you guys have on the test regions? Hopefully it feels a little easier than last time you learned it. Okay, one more. This one is, we don't have to do a number line to figure it out. We just basically just set it up and solve. So we want to know when k is less than or equal to -31. So I'm just going to take it and set it less than or equal to -31. Right, and then just kind of solve it like it's an equation. Except there are some rules about inequalities you need to make sure you remember. But we'll subtract that 1. Right, and then we're going to want to divide by -4. So what happens on the inequality when you divide by a negative? Right. Now, I said earlier, I feel like I keep telling you stuff that's not always true, and it's not good. I said earlier that the only way to get an exponent down is to use logarithms. That's not necessarily true. We can get it down another way on this one, and it's by writing each side with the same base. Using a logarithm on this one, you could still get there, it would just be way harder. And so I can write 8 as 2 to a power. What power? Yes. So then I can take, since they have the same base, and drop down the exponents and then solve it really easily by adding 3. So as long as x is greater than 6 or equal to, then that function will be greater than or equal to negative 31. All right, now I have a problem from your homework written down that I want to talk about because we didn't do. I'm not going to do it for you, but I'm going to help you get it set up. This is number 14 on your homework. It is a calculator allowed question. If it's a calculator allowed question, I don't want you to go through all the steps that we just did to solve it because it would be a total waste of time. So this is what we're going to do. We have this function f that's log base 2 blah 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 minus another log base 2. And we want to know for which values of f or which values of x is it less than 5. All right, so everyone grab your calculator. And let's go to y equals. And we're going to put f in for y1. You guys remember how to do log base 2? Some people do, some people don't. All right, we're going to do alpha window, and then number 5 is log base 2. I'm going to have to move up a little bit. And then make sure you come out of those parentheses. I messed up when I was typing one in. I was working out the answer key. All right, and then minus. Log base. Whoa. That was wrong. I don't want to start over. Okay, so that's f. If I want to find when this is less than 5, what do you think I should put in for y2? Yeah. And then we'll look at the graph. All right, so you can see, basically it's going to be less than here. Now the logarithmic graph doesn't stop there. It keeps going up, 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 but your calculator for some reason can't draw it right. I don't know. It's a glitch in the calculator. And so with the, oh no, there we go. So the answer to the question is going to be from wherever these cross all the way to infinity, then the blue graph is going to be less than the 5. So I'm not going to do it for you. You'll have to find it. It looks like it's 1, but it could be like 1.2 or something. So find where they intersect. If you need help, remember how to do that. Let me know. And then it's going to be from that to infinity.